Alright y'all, so in this video I'm going to talk about the conic section of hyperbola. Just as a reminder, the definition of a hyperbola is the locus of points in a plane such that the absolute value of the difference of the distance from two points that we call the foci is constant. And in terms of our overview of conics that we went over at the beginning of the unit, hyperbola comes from a double napped cone in which our cross section is perpendicular to the base of the cone. Then you'd see like this that the cross section looks like a hyperbola. So in this problem it says to graph the following conic section, which when I look at the equation I know that it's a hyperbola because I see that it's the difference right here of these two fractions, and it looks like it's in the form that we learned for a hyperbola. And then it says to identify the center of the foci and the asymptotes once we're done. So let's go ahead and kind of walk through how I would sketch a picture of a hyperbola like this one. So I'm going to kind of start almost like I did with the ellipse by starting with my center, and it asked for the center, so I'll go ahead and identify that as well. So the center is going to come from my h and k the same way I found it before, so 2, -1, so I'm going to go over 2 and down 1 and find my center. And then similar again to the ellipse, I'm going to use these numbers underneath on the denominators to figure out how much to go left and right and how much up and down. Since this is a 4 on the bottom, 2 squared would give me 4, so I'm going to go 2 to the left and the right. And then underneath my y term is a 9, and 3 squared is 9, so I'm going to go 3 up and down. 1, 2, 3, 1, 2, 3, like that. And instead of drawing an ellipse, since this is a hyperbola, I'm going to use this to draw a box. And this box is basically going to give me my asymptotes. My asymptotes are going to be the diagonals of this box right here, and we'll write the equations for those in just a second. Okay, now that I have those, I can draw my hyperbola, and my hyperbola can either be a vertical hyperbola like this, with these as the vertices, or it could be a horizontal parabola like this, with these 2 points as the vertices. So if I take a look at my equation, because it's leading with my x term, I know that this is going to be a horizontal. If it would have been leading with this y term, then it would have been vertical. So I'm going to take this and I'm going to draw a horizontal hyperbola approaching these asymptotes. That looks like this. So these two pieces are my actual hyperbola itself. Let's go ahead and find the foci, since I'm also asked for that. Now remember, to find the foci we need to use our c value. We need to find c, because c is the distance from the center to the foci, and I can find c because c squared equals, for a hyperbola, a squared plus b squared. So I'm going to add my denominators and say c squared will equal 4 plus 9, which is 13. So c is going to be equal to plus or minus root 13, which if I want to draw on the picture, the square root of 13 is between 3 and 4, so 3 point something. So I'm going to go 1, 2, 3 and a bit, 1, 2, 3 and a bit, so that I can sketch those foci right there. And that means that the coordinates of those, I can see now that I drew them, that the y coordinate is definitely for both of them -1. It's in line with the center. And the x coordinate is going to come from, I started at 2 and I went forward, so plus root 13. And I also went, starting at 2, minus root 13, or backwards root 13. It's a little hard to read. So 2 plus root 13, comma -1, 2 minus root 13, comma -1. Okay, and last but not least, it asks for the equations of the asymptotes. So the asymptotes are just lines, so I'm going to use point slope form, which as a refresher is y minus y1 equals m, in this form right here. So if I have a point x and y, which I do, I could use the center, for example. I could say y minus -1 or y plus 1 equals my slope times x minus 2. And my slope I could find by just looking at my box right here. It looks like I'm rising 3 for every 2 I run, but I have both the positive slope and the negative slope of that. So I'm going to say y plus 1 equals plus or minus 3 halves as my slope times x minus 2. So these would be the two equations of my asymptotes, one with a positive slope, one with a negative slope. And there you have it. Here's our parabola with the following characteristics that they asked us to find.